সবাই কেমন আছেন? ভালো তো? সুপ্রভাত, শুভ দিন, শুভরাত্রি। উম যেকোনো সময় আপনারা দেখছেন আমার ভিডিও। Thankful of that. So we will be talking today a little bit about statistics. Basically, we will discuss about sampling distribution of sample proportions. So before I get started, please subscribe to my channel by hitting the red subscribe button, and please share this video with your friends if you like it. So, we are going to talk about, as I said, sampling distribution of sample proportion. Of sample proportion. P hat. This is written by P hat. Why do we work with sample proportion? Our ultimate goal is to find out the population proportion of success. I'll give you an example. For example, if I want to find out what proportion of students at a particular college which has 10,000 students have laptop computers, I have no way, the time and the energy and the money to contact all the 10,000 students. So, what will I do? Instead of working with the entire 10,000 students, population of 10,000 students, I will work with a simple random sample of, say, size 100, selected from that population, and ask each of these 100 students, how many of you have laptop computers? Say if 80 out of those 100 selected students have laptop computers, then my P hat, which is the sample proportion of success, is given by number of success divided by sample size. Now, number of success is given by x and sample size is n. In my example, P hat, since 80 students out of 100 have laptop computers, it will be 0.8. Now remember, this is only one sample of size 100, simple random sample that gave me a sample proportion of 0.8. Now remember, my population size, entire population size is 10,000. Out of that, I have selected only one sample so far, simple random sample. I can select many samples of same size, 100, and get many values of P hat. Finally, I can do a relative frequency distribution of P hat. That is, I will draw P hat on the horizontal axis, different values of P hat, okay, and relative frequency on the vertical axis. Relative frequency is same as probability. And we will say start at the lowest value of P hat in my samples and divide them into small groups of equal size, 100 for example, okay. Sample size is 100, all of the sample size 100, and I'll divide the P hat into groups of equal size. Now, on top of each of these groups, this is the lowest value of P hat, this is the next value of P hat, this is in width, and which I have selected, and all of these widths are the same of each of the classes. And I draw a vertical rectangle on top of the first group. What is the height of the group? Height of this first group is the relative frequency. That means what proportion of the entire sample of the same size 100 fall in the first group. That is, what is the proportion of all of those samples that have P hat, sample proportion values between the lowest and the next value. And I can continue. So the heights are the relative frequency or proportion of the entire values of p hat that fall in each of these classes. Okay. Next one, if I draw, will be like this. Okay. Again, these are equal width of, or equal width of p hat. So class widths are the same, different width values of p hat. And then I can draw, I can join the top roofs. For example, the next one will be like this. Basically, I'm joining the roofs of each of these vertical rectangles. The heights are the relative frequency or the proportion of entire p hat values of all my samples that fall in each of these classes. Okay, so basically I have relative frequency on the vertical axis, p hat value on the horizontal axis. Joining the roofs by a smooth curve, I get a bell-shaped distribution, which is called a sampling distribution. This is the sampling distribution. That means nothing but probability distribution of p hat. Okay, probability distribution of p hat. Now by central limit theorem, CLT sometimes called central limit theorem, the sampling distribution of p hat, okay, it has a peak, it's a bell-shaped distribution. It has one value of p hat on the horizontal axis, which has the highest relative frequency, and this is over here. So this value where the peak is located in the sampling distribution is the center of the distribution where the mean is located. Now by central limit theorem, mu p hat is equal to p. What is p? Is the population proportion. So you can now see the advantage of collecting these samples of the same size and finding the sample proportion in each case, and then doing a relative frequency diagram and then joining the top roofs of the vertical rectangles. Remember, the heights are relative frequency or proportion of p hat in each group. When I complete the bell-shaped curve by joining the top roofs with each of these vertical rectangles, the peak where the relative frequency is the highest is the center of this distribution, or the mean of this distribution, and it is equal to the population proportion. Did you catch it, what I said? So the center is the population proportion. I did not know the population proportion, but by doing this experiment, I can get the peak, and therefore I can locate the population proportion, which is the center or mean of this distribution. How about the spread in this distribution? That is given by sigma p hat. It is the standard deviation of this distribution. That means sigma p hat gives us an average of deviation of p hats, or difference of p hats from the center, which is, we already know, is p. Okay, now there is a formula for sigma p hat. The standard deviation, it's given by this formula, square root of p times 1 minus p over n. So you ask, what is p? P is the population proportion. So again, just reminding you, the advantage of central limit theorem is we locate the peak on the horizontal axis where the relative frequency is the highest of the bell-shaped curve. That is the population proportion. Okay, and that this way we locate the population proportion without reaching the entire population. Okay, and the standard deviation of this curve, sampling distribution of p hat, is given by this formula. Now we are going to use this bell-shaped diagram sampling distribution of p hat to estimate the minimum sample size necessary. But before I do that, let me tell you draw you the standard normal curve. This is my standard normal curve. That means it is a Z. Remember, Z is the standard normal variable. Z is the standard normal variable. And what is the definition of Z? Is X minus mu by sigma. So what is my X? X is any value in the distribution. X is the random variable that I'm measuring. People's height, people's weight, people's income. If I'm measuring people's weight, then mu is the mean of the population. Mean of the population of weights. Okay, mean of the population. And sigma is the standard deviation of the population of the variable that I'm measuring. Maybe it's people's weight. Okay. So we can use the same information, and this is the standard normal curve, this bell-shaped distribution. Why it is called standard normal curve? Because you have the standard normal variable plotted on the horizontal axis. What is the advantage of this curve? Okay. The advantage of this curve, if I plug, if x is equal to mu, then what happens to z? Z is equal to mu minus mu by sigma, or 0 over sigma, which is 0. That means the center of this curve is z is equal to 0. Now you know on a number line, if 0 is in the center, this side will be positive on the right of 0, and this side will be negative. Okay. Now suppose, so the mean is 0 for standard normal curve. Standard normal curve, mu is equal to 0, as I just showed you by plugging in x equal to mu. Okay, so mu is 0. How about sigma? Okay, suppose we are one standard deviation away from the mean. Okay, so okay, let's locate a point. Remember, this is 0, this is sigma, because we are one standard deviation away from the mean. Okay, now let's plug in. Remember, for z will be x, which is one standard deviation away. So this point is sigma, because we are one standard deviation above the mean. So sigma away from 0, minus mu is 0 divided by sigma. So what is this? Sigma by sigma is 1. So what is the bottom line? When you are located one standard deviation above the mean, your z-score is 1 on the z-scale. And when we are located one standard deviation below the mean, remember this is minus sigma. Why? Because you're on the left of 0. This one will be minus 1. So basically all this is to introduce that z gives you how many standard deviation, you are above or below the mean. How many standard deviation you are above if z is positive. If z is positive, and or how many many standard deviation below the mean if z is negative. Standard deviation below the mean if z is negative. Okay. So bottom line, if z is positive, it tells us how many standard deviation you are above the mean. So if z is 2, that means you are 2 standard deviation above the mean. If z is negative, such as -2, that means you are 2 standard deviation below the mean. This is the property of standard normal curve. Mean is 0, standard deviation is 1. Okay. So for the standard normal curve, mean is equal to 0 and sigma is equal to 1. Okay. So with this background, we will use the sampling distribution of p hat to find out sample size. You ask me how? Let's turn the board and do it on the other side of the board. Okay, so let's do the standard deviation, the sampling distribution of p hat, where you have p hat on the horizontal axis, and this is the curve. This is the sampling distribution of p hat. Its mean is equal to the population proportion, and sigma, standard deviation sigma p hat, is square root of p times 1 minus p over n. So at the center, mu p hat is equal to p. Okay, population proportion. Okay. Now if you convert this to a z curve, same information in a z curve, the center will be z equal to 0. Okay. And if you are 1 standard deviation away, okay, so this is a value of 1, this is 1 standard deviation. Value of 2 means another 1, 2 standard deviation. On the left it is minus a little bit more, -1, -2, and so forth. How many standard deviation you are below the mean? Same information over here. So suppose you select a point whose z-score on this axis is z, okay, alpha by 2. I will introduce those concepts later on. So if this z-score of this point is z alpha by 2, then it is how many standard deviation away from the mean is multiplied by sigma p hat. Okay. Now you will ask immediately, and if you are on the left hand side on this, it will be minus z alpha by 2 times the standard deviation, which is sigma p hat, this distance. Okay, and this distance is positive. With the same idea, 1 standard deviation, mean is 0, so 1 times standard deviation, which is 1, 1 standard deviation above the mean, 2 standard deviation above the mean, 1 standard deviation below the mean, 2 standard. Now when we are doing the confidence interval of the population proportion, interval for population proportion P, that is, we do not know what exactly is the population proportion value, but at least we can locate an interval or a range of numbers within which the population proportion will fall. And we draw two boundaries, a lower boundary and an upper boundary. My drawing is not so good at all. Let me make this a little better. So maybe something like this, just to keep the same height. Okay. So this point is located minus z alpha by 2 times the sigma p hat standard deviation, same as this point is located here. The z score is minus 1, here the z score is positive 1 times the standard deviation. Remember, for this curve mean is 0, sigma is 1. So actually this point is located z score of 1 times the standard deviation of 1 above the mean. Similarly, this point is located z score times the standard deviation of this sampling distribution. Now the question is, what is alpha? Okay, alpha is 1 minus c, where c, this is alpha, where c is the level of confidence. Usually we use a level of confidence of 95%. What does it mean? It does not mean there is a 95% probability that the population proportion will fall within this interval. What it means, usually 90.95. That means we have faith in the method that we are using. That faith or confidence is 95%. That means if I collect 100 samples of the same size and get 100 of these intervals from these 100 samples, out of those 100, 95 intervals will contain the actual population proportion. So the confidence level is the effectiveness rate or the success rate of the method that we are using to determine the interval. It is not the probability, it is a success rate. Out of 100 intervals, 95 intervals will contain the actual population proportion. And alpha is like a complement or opposite of the level of confidence. That means alpha is where we are not sure. So if c is 0.95, then alpha becomes 1 minus 0.95 is 0.05, sometimes called the level of significance. That is, we are taking a risk of 5%, or 5 out of 100 intervals will not contain the actual population proportion. So that is our level of risk we are taking, that we will not get the actual interval. So this entire area is where in the center, okay, at a distance of z alpha by 2 times sigma p hat, negative on this side, positive on this side. This is where most probably the population proportion, this is my confidence interval, the center area, confidence interval. Okay. Again, the boundary on the right is z alpha by 2 multiplied by the standard deviation of this curve, which is sigma p hat. Okay. Same idea over here. This is z equal to 1 and this point is located 1 times the standard deviation of this curve is also 1. Okay. And this is located minus 1 times the standard deviation, which is also 1. Same idea over here. Now, question is, what is the z alpha by 2? Notice these z alpha by 2 on the right and minus z alpha by 2 on the left. Okay, it should be a little bit high. Okay, they form the boundaries within which most probably the population proportion will fall. This is the center, is the most probable region where P will, population proportion P will fall. And the shaded region in the tail are the least probable. This is least, this is least. So this z alpha by 2's on the right and minus z alpha by 2 on the left plus minus z alpha by 2 is called critical values of z. Why it is called critical? As I explained, the white area is where most probably the population proportion will fall. The shaded area in the two tails least probable region where the population proportion will not fall. That is why these are called boundaries, because they separate the most probable region from the least probable region. Now, how to find this z alpha by 2? What is the value of this z alpha? It of course depends on the level of confidence that we select. If it is 0.95, then alpha is 0.05. Okay, alpha is, so from so this C level, C is equal to, from here we can write C is equal to 1 minus alpha. So area in the center is 1 minus alpha. Alpha is 0.05, C is 0.95. So this is, for this case, is 0.95 in the center. This is the central area. 95% our success rate is 95%. So the population proportion will fall in this interval. We are 5% risk we are taking that we will not catch the actual population proportion, or 5 out of 100 intervals will not contain the actual population proportion. So the area in the center is 1 minus alpha. Area in two tails, in dense, if the central area is 1 minus alpha, what is left in the two tails is just alpha. Now of course this curve is symmetric. Because of symmetry, symmetry means left half equal to the right half in a standard normal curve. Left half is equal to the right half. Because of symmetry in standard normal curve or normal curve, area in each tail is half of alpha. Each tail is equal to alpha by 2 is 0.025 in our case. 0.05 divided by 2. Let me write it down. 0.05 divided by 2 is 0.025. So that means this area is 0.025. This area is also 0.025. Now this will help us, because we know the area in the tail is 0.025, to locate this minus z alpha by 2. Remember, this point is minus z alpha by 2 times the standard deviation away from the center. So we will use our calculator to find this minus z alpha by 2, because the area in the left tail is 0.025. So if I have a TI-84 calculator like this, okay, I will press the second key, then the verse key, and then I will select number 3, which is in norm function, inverse of normal. And the first thing it asks for is area. We'll type in the area in the left tail as 0.025. The mean is 0 because it's dealing with this curve, and sigma is 1. These are already set up in the calculator. Then we'll go down to paste and hit enter twice. Enter twice. Okay. And the minus z alpha by 2 will come out as 1.96. Again, how do I do it? I put the calculator on, second button, then the verse button, which is in the third row, second and verse, then number 3, in norm, area in the tail, left tail is 0.025, mean is 0, standard deviation is 1, and I go down to paste and hit enter, and again enter, and it is minus 1.96. So this particular z value is minus z alpha by 2 is minus 1.96. By symmetry, this z alpha by 2 on the right of the center is positive 1.96. So bottom line is we want to calculate the 95% confidence interval for the population proportion. So we know the center is P. Okay. population proportion. So actually the 95% confidence interval for P population. Remember, we do not know the population proportion actually. Is given by sample proportion P hat. Remember, P hat is the sample proportion, plus and minus, plus on the right, minus on the left. The critical value of Z times sigma P hat. Okay. Now, this plus or minus is called the margin of error. M is your margin of error. The whole thing, margin of error, which is equal to Z alpha by 2 times sigma P hat. And M is equal to Z alpha by 2 for sigma P hat. I can write the entire formula, which is the standard deviation of the sampling distribution P hat is P times 1 minus P over N. So let me summarize what I did. From the sampling distribution, I know the center of this curve is at P. So the center or the mean of the sampling distribution of P hat is P. Sigma P hat is given by square root of P times 1 minus P over N. I got this from the central limit theorem. And now I am dealing with a confidence interval for population proportion. Of course, I do not know the exact population proportion. At least I will look at a lower boundary and an upper boundary within which most probably the population proportion will fall. How will I know? How will I get it? If I have 95% confidence in the method that I am using to determine the interval, then the area in the center is 0.95, which is 1 minus alpha. Confidence level C is 1 minus alpha is 0.95. And alpha is the area in two tails, 0.05. That is called level of significance. That is the maximum risk we are taking that we will make a mistake in determining the interval for population proportion. That is 5 out of 100 intervals will not contain the actual population proportion. And that alpha of 0.05 is called level of significance. So area in the two tails is 0.05. Why? Because these are the tails where the population proportion will most probably not fall. So this Z alpha minus Z alpha by 2 on the left, positive Z alpha by 2 on the right are called critical values. Since we know this curve is symmetric, area in the left tail is equal to area in the right tail, area in each tail is alpha by 2 is 0.025. This is a critical information because using this we will find out the critical value of Z, which comes out as minus 1.96. I will use my TI-83 calculator in that case, TI-84. Second verse 3 is in norm. Area in the tail is 0.025. Mean is 0. Sigma is 1. Why? Because we are dealing with the standard normal curve whose center is 0. Mean is 0. Standard deviation is 1. This is the standard normal curve. Standard normal curve whose Z is 0 and standard deviation is 1. Okay, so using that information, I find the critical value of Z as minus Z alpha by 2 is minus 1.96. By symmetry, positive Z alpha by 2 on the right of the mean is positive 1.96. Why do I need this information? Because that Z alpha by 2 multiplied by the standard deviation of the sampling curve of P hat, it gives you the margin of error. So if we know the sample proportion, we can calculate the margin of error. The plus sign will give me the right boundary. The minus sign will give me the left boundary of the confidence interval. Okay. In our case, we are dealing with 95% confidence interval. Okay. So this is the equation for margin of error. So if you ask me what is margin of error, it is the difference between sample proportion, which is p hat, minus the population proportion. So from this equation, I can square on both sides. Square on both sides. Why will I square? Because then I can get rid of the square root. If you square a square root, you are going to get the quantity inside the square root by itself, and we remove the square root. So squaring on both sides, we get m square is equal to z alpha by 2 square. And as I told you, by squaring the square root, we eliminate or remove the square root. P times 1 minus p over n. Okay. My goal is to solve for the sample size n. Okay. So multiply by n. Why are you multiplying by n? Because this is division by n. It's in the denominator. In order to eliminate it, I have to do the opposite of division. This line is division, which is multiplication. When I multiply on one side, I have to multiply on the other side by n2, because this is an equation. So this n cancels with this n. On this side, we have n times m square is equal to p times 1 minus p. So we have n multiplied by m square is equal to z alpha by 2 times p 1 times 1 minus p. Okay, now I will divide by m square on both sides. Why? Because my goal is to separate n by itself. And this z alpha by 2 is squared. Okay, and I'm dividing by m square. Okay, so when I do that, this m square cancels with this m square on the left hand side, and I get n equal to z alpha by 2 divided by margin, the whole thing is squared, times p multiplied by 1 minus p. Okay. So that is the equation for minimum sample size. Again, n is equal to, let me write it the way it is written in textbooks, p times 1 minus p multiplied by z alpha by 2 divided by margin square. N is your minimum sample size necessary. Minimum sample size necessary. Necessary for 1 minus alpha level of confidence and m margin of error. And margin of error, which is the difference between sample proportion and population proportion, and m is the margin of error. So this is the formula we are going to use to calculate the minimum sample size necessary to maintain a particular margin of error m at 1 minus alpha level of confidence. Okay. So the question is, how will I apply this formula? Okay. So again, I wrote the equation for margin of error, which is the plus minus term. Okay. And it is the critical value of z alpha by 2 multiplied by the standard deviation of the sampling distribution, which is square root of p times 1 minus p divided by n. I want to solve for n, minimum sample size. So I squared on both sides and then multiply by n. Then I solve for n, and this is finally what I get. So let's go on the other side of the board and try to work out on a problem using this formula that I just now derived. Okay, so let's erase all this. So the minimum sample size formula is minimum sample size formula for sample proportion for shouldn't say sample proportion for population proportion P and margin of error M is given by n equal to P times 1 minus P multiplied by Z alpha by 2 by M square. Now if C is equal to 1 minus alpha is equal to 0.95, C being the level of confidence, we already showed Z alpha by 2 is 1.96. Suppose my margin of error, suppose M, which is margin of error. Again, to remind you, margin of error is the difference between the sample proportion minus population proportion. If M is equal to 0.1, okay, then N is equal to P times 1 minus P. For 95% confidence, Z alpha by 2 is 1.96 divided by margin of error is 0.1, and you're going to square this. So let me use my calculator. I will do this calculation. 1.96 divided by, so I will do it this way. What I will do is I will put a parenthesis, left parenthesis or left bracket. 1.96 is the Z alpha by 2 value divided by margin of error is 0.1, right parenthesis. I squared the whole thing and hit enter. Okay, so 1.96 divided by 0.1 square is 3. So this is N equal to P times 1 minus P times 384.16 for the whole thing in the parenthesis. 1.96 divided by 0.1 squared it. Okay. Suppose P is not given to us. Population proportion is not known. Then the textbook says assume P is equal to 0.5. Then assume P is equal to 0.5. So N is equal to then 0.5 times 0.5 times 384.16. Okay, so what is N? So it is multiplied by 384.16 multiplied by 0.5, then again multiplied by 0.5. And it works out to 96.04. But this is incorrect. We always round it up to the next higher number. N is 97. Okay. So we always round it up. 0.04, we do not round it down, we round it up. Again, to summarize what I did, this is the sample size, minimum sample size formula. N equal to P times 1 minus P multiplied by critical value of Z divided by margin of error square. Now Z alpha by 2 is the critical value of Z is 1.96. Margin of error will be given to us in the problem, which is sample proportion minus population proportion. If it is 0.1 and if my level of confidence is 0.95, Z alpha by 2 is 1.96, margin of error is 0.1, 1.96 divided by 0.1, square it is 384.16. Most of the time we do not know the population proportion. In that case, we will assume population proportion as 0.5. So N is 0.5 times 0.5. 1 minus 0.5 is also 0.5. times 384.16. Sample size comes out as 96.04. This is incorrect because we have to round it up. We do not round it down to 96. We round it up to next sample size is 97. So this is the correct answer in this case. So I am going to stop here today. If you have any question, any comment, please do not hesitate to drop me a line. I will respond to all your comments, all your question. Promise. আপনাদের প্রশ্ন থাকলে প্রশ্ন করুন, নির্দ্বিধায় আমি সবাইকে উত্তর দেব। ঠিক আছে, আজকে এখানেই শেষ করি। ওকে, শুভরাত্রি। Hopefully I'll see you tomorrow. I'll be back tomorrow with another interesting video. Please subscribe to my channel by hitting the red subscribe button. And please also do not forget to click on the notify button, because in that case you will be notified every time I upload a new video. Thanks for watching. If you like this video, share with your friends and give me a thumbs up. That motivates me to produce more videos just like this. Okay? I will see you later. Take care. Have a nice day. So basically in this problem, we worked out the formula for the minimum sample size, starting with the confidence interval formula, margin of error formula, the sampling distribution of sample proportion, its mean, its standard deviation, all this taken into account, from which we get the sample size formula. And I worked out a problem where we do not know the population proportion. In that case, we'll assume it to be 0.5 and calculate, and then we round it up, of course. Okay, I'll stop here today. Again, any question, just shoot me a comment. I'll get back to you as soon as possible. Thanks for watching. Take care. Have a nice day.